Hi, welcome to another harmony class. This is the first part of the lesson on negative harmony. A lot of interest and a lot of hype has been generated about what is called negative harmony, especially after the incredible Jacob Collier talked about it, and especially in an interview with another extraordinary musician, Jun Lee. However, it is hard to find a single source where the concept is explained clearly and comprehensively. So if you really want to learn and understand negative harmony, please stay with me. My name is Pedro Dias, and if you're enjoying the videos, please share and subscribe. One possible short definition of negative harmony is notes that are related through intervallic inversion around an axis that is specific to each key. Okay, I know it's not enough, but it will get clear. First, we need to know what is intervallic inversion. And I believe that the easier way to do it is through images. That's why we'll use the circle that represents the pitch class space. The pitch class space is usually represented by a circle with 12 points, like a clock face. Each point represents a pitch class, and the 12 o'clock position, or 0 as it is usually called, represents pitch class C. Why pitch class? Because it represents any C or every C in any octave. At 1 o'clock we have the C sharp or D flat, and so on. The pitch class space is a visual aid to the understanding of many musical elements, intervals, chords, scales, etc., and intervallic inversion. Chords and other structures can be represented in pitch class space as geometric shapes. The C major triad, for instance, can be represented like this. All major triads have the same geometric shape. As we slide this shape along the circle, we have all transpositions of the major triad. D flat or C sharp major, D major, and so on. Now, the intervallic inversion is obtained by flipping the shape around an axis, say an axis drawn over the pitch classes C and F sharp. As we flip the shape around this axis, each pitch class will map onto the pitch class at the corresponding position at the other side of the axis. In this case, the pitch class C will map into itself, as it is over the axis. The E maps into A flat, and G is mapped onto F. So, as we flip the shape over this axis, we get C, A flat, and F. That is, the F minor triad. So we can say that the intervallic inversion of the C major triad around this axis is F minor. Now, the intervallic inversion is obtained by flipping the shape around an axis. Let's represent this in a different way. The intervallic inversion is obtained by going the same distances of the intervals that form the structure, but in the opposite direction. If in C major we have a major third and a perfect fifth above C, we have to go a major third and a perfect fifth from C downwards. Then we get A flat and F, which with the C form the F minor triad. F minor is the intervallic inversion of C major. Here our axis is the C, and A flat and E are equidistant from this axis, as are G and F. C major inverted is F minor. Let's get back to the pitch class space. We have here the geometric representation of the C major and the F minor triads that are related by intervallic inversion around the central axis, the axis over pitch classes C and F sharp. As we invert a major triad, we always obtain a minor triad, but which minor triad depends on the axis around which we do the inversion. If we change the axis, we change the transposition of the inversion. Let's move the axis so that it is over pitch classes B and F. Now C maps onto B flat, E onto F sharp or G flat, and G onto E flat. Therefore, as we invert the C major triad over this axis, we obtain the E flat minor triad. The axis has 12 possible positions, 6 that are over each pair of pitch classes, and 6 that are over the midpoints between pitch classes, like this one here. Around this axis, E maps onto E flat, and C and G map one onto the other, because they are located at the same distance from the axis. When C major is inverted around this axis, we get the C minor triad. And it is precisely this axis, located at the midpoint between C and G, that is used in negative harmony in the key of C. So, the axis around which the intervallic inversion we call negative harmony is performed is the axis that is placed in the midpoint between the first and the fifth degree of the key. Now we can update our definition. Negative harmony is notes or groups of notes that are related through intervallic inversion around the axis that is the midpoint between the first and the fifth degree of the key. Here we can see all the intervallic inversion relationships around this axis. Pitch classes at one side of the axis map onto pitch classes at the opposite side of the axis. It is easy to find these correspondences in the keyboard. If you play the two notes between which the axis is located, in this case A and B flat, or it could be E and E flat with the same results, you can just move upwards with one note and downwards with the other, chromatically, and you will find each pair of related notes. Here we have the notes of the C major scale, and below them the corresponding notes that are placed at the other side of the negative harmony axis. That is the C negative major, so to speak. This scale can be seen as a G Phrygian, or it can be seen as C natural minor. And that is why negative harmony chords sound similar to modal interchange chords. They belong to the natural minor scale of the key center. Another peculiarity of the inversion around this axis in particular is that each unstable scale degree maps onto an unstable degree of the other scale. Unstable notes, here in red, are notes that don't belong to the tonic chord, and they traditionally attract or tend to resolve on stable degrees, that is, on notes that belong to the tonic triad. Therefore, chords related by inversion around this axis have the same quality, be it a stable or an unstable quality, and so they have the potential to be functionally interchangeable. Another way of representing the pitch class space is with the cycle of fifths. Here the sequence is not chromatic anymore, but by fifths or fourths, depending on how you see it. Here the axis is still in the midpoint between C and G, and the pitch class correspondences are the same. We can use the same diagram to represent related triads. At the right side, we have the triads of the C major key, and at the left side, the corresponding negative triads, those that belong to C natural minor. A progression which is in the cycle of fifths, such as a 2-5-1, when inverted, arrives at the tonic chord from the opposite side of the cycle of fifths, that is, a flat seventh, 4-1. When we add sevenths to the chords, something interesting happens. The majority of the negative chords change root notes. G7, for instance, maps onto D half diminished. In order to keep the same relationship between root notes that happen with the triads, we must consider the negative chords not as seventh chords, but as added sixth chords. For example, the negative of G7 is D half diminished. But if we want to keep the same distance from root notes in the cycle of fifths, we must consider this D half diminished as an F minor with an added sixth chord. Instead of G minor seventh, which is the negative for D minor seventh, we have to consider it as a B flat with an added sixth, and so on. So a 4-5-1 progression of 4-note chords like this, when inverted, sounds like this. If we add ninths, it is still more difficult to keep the relationship between roots consistently in the cycle of fifths. Then we see that the system has its limits regarding to the consistency of one of its attributes, as proposed by Jacob Collier. And things get even worse if we use chords with omitted fifths. The system is coherent, however, as a system of relationships between notes and groups of notes, regardless of this cycle of fifths issue and of being a source for traditional harmonic substitutions or correspondences. It is as coherent as any other system of intervallic inversions. After all, this idea of inverting intervals is not a recent one by any means. Many composers have used it in one way or another, from Bach to Rachmaninoff and many others. In the next video, we will investigate how composers have used the concepts of negative harmony, as well as suggest some practical possibilities. Until then, let's look at one of the more simple ways of using negative harmony, which is harmonic substitution. In this example, some chords were substituted by their negative versions, which are colored red. Let's hear it. Thanks for watching, happy practicing, and see you in the next video.